Welcome to myprojectbazaar.com. Our product title is VLSI Architecture for delay efficient 32-bit multiplier using Vedic mathematics. Let us see about the abstract of our product. The digital architecture is mainly used in all type of real-world application architectures, and thus the architecture to modify based on the enhancement purpose. The VLSI technology is to optimize the any type of digital architecture. Multiplication is an important fundamental function in arithmetic logic operation. Computational performance of a DSP system is limited by its multiplication performance, and since multiplication dominates the execution time of most DSP algorithms, multiplication is one of the basic arithmetic operation and it requires substantially more hardware resources and processing time as addition and subtraction. Vedic mathematics is the ancient system of mathematics which has unique technique of calculation based on 16 sutras. Two sutras among 16 sutras of Vedic mathematics can be applied for implementation, and Nigilam Sutra and Uddhava Sutras are used to implement for multiplication process in Vedic multiplier. In this proposed multiplier implementation, VLSI architecture for both sutras is implemented and synthesized in Styling software. The delay and memory for multiplier using Uddhava Sutra are less when compared to multiplier using Nigilam Sutra. Further, the structure of Vedic multiplier is modified by using binary to XS1 code converter so as to obtain less delay for the multiplier by replacing normal address with binary to XS1 code converter. In multipliers, we can achieve reduction in delay process. In this proposed implementation is done in Styling software tool. Next, we see about the flow diagram of our product. In this major process is a Vedic multiplier process. In the Vedic multiplier process, totally for example 15-bit data, first 4-bit data is considered as to 4 cross 4 multiplication. Then after that 4 bits are considered to 4 cross 4 multiplier up to 16th bit. So after that the multiplication in output is 8-bit data. That 8-bit data is fed into the full order function. In that full order function, two kind of processes is done. After that, that is fed into the full order. Finally we get the 32-bit output. In our flow, applying 32-bit input bits is fed into the Vedic multiplier. Then the Vedic multiplier is fed into the BC converter, binary to XS code converter, and addition process is done using of the output of binary XS code conversion. Then that is fed into the 32-bit multiplier architecture. When simulation and synthesis result analysis will be done. So that result analysis is compared with the Nigilam and Uddhava Sutras. Generally, the speed of the processor determines its performance. High speed processing is an essential requirement for all the system. Multiplication is a significant operation in digital signal process and arithmetic logic unit, and thus the demand for high speed multiplication is continuously increasing in modern VLSI design. Our research focus is on high speed multiplication using Vedic mathematics. Earlier, some multiplier like both multiplier and modified booth multiplier and array multiplier were considered for high speed multiplication, but these multiplication involve large number of intermediate steps which reduce their speed with increases in number of bits for high speed multiplication as well as to increase the performance of multiplier. Vedic mathematics techniques are used. The Sanskrit word Veda is derived from the root with meaning is known without limit. Swam Bharati Krishna called a set of 16 sutras, and 2 sutras is used for the multiplication process. So in that 2 sutra is considered 2 for the processing of the multiplication. So here we using Uddhava and Nigilam Sutra for the multiplication. Next we see about the running process of our product. In this proposed implementation is done in Styling software. First open the Styling software and create the new file. After creating the new project file, we assign the which kind of coding we go to develop. So here in this proposed implementation is a VSTL based coding. So we click the VSTL module. So after that, two kind of output can be shown. So first one is the simulation. In simulation, we select the main file, then run the behavior model, then corresponding output will be shown. And next one is the implementation design. In the implementation design, first we click the synthesis XST, then that starts to run. After starts to run, they click the implementation design. So then the corresponding output will be shown. In the synthesis XST, we go to see the various kinds of output. First one, synthesis report. In the synthesis report, having design summary and design utilization summary. So in the design utilization summary, how much amount of LUT we used, and how much amount of slice register we used, and how much amount of input output bonded we used. So those kind of utilization is shown in that block. So here number of slice register is 64 out of 1,26,800. So and also number of LUT is 2,389. And next one is the number of flip-flops, 2327. And also number of bonded input output is 129. So these are the device utilization summary. Next output is a timing report. In the timing report, the timing summary is shown. In the timing summary, total combinational batch delay is 9.08 nanoseconds, and maximum arrival time is 25.23 nanoseconds and 0.7004 nanoseconds. So total time is calculated here. So we can see total amount of nanosecond is 25.239 nanoseconds. So overall the nanoseconds are shown. So next one, we can see the view RTL schematic. So click the OK, then set the create schematic. So here what's the input, what's the output? Input is 31 bit, and two kind of inputs we give, A and B, and using of clock the output will be displayed, and also the output is 64 foot. Those kind of output schematics will be shown this. Next one, we can double click that which blocks what elements we used. So that is used in that schematic diagram. Next one is the technology diagram. In the technology diagram is also same procedure. So click that and create a schematic, then corresponding will be open. So here current selection, so give yes, so corresponding output will be displayed. So in the power, corresponding power consumption is using various kinds of silent software Excel sheet. So in that Excel sheet we assign the values of the LUTs, flip-flops. Those values we entered, the corresponding power consumption will be calculated. So overall process is implemented this kind of way, and also this way is similar to the Urtava process. Thank you for watching this video.